Hey guys, so today I'm making a video introducing momentum, and the formula for momentum with symbol P is mass times velocity. And you might ask, why is it mass and velocity? What's so special about them together? Well, actually, what's special about them is that they're conserved before and after a collision or an explosion. And what I mean by that is if you have one ball and it is going at speed v1, let's say, and then it hits another ball and they go off in directions like this, and let's say this is v2 and v3, then you could set up an equation. You can say this is m1 and this is m2. So m1 v1 equals m1 v2 plus m2 v3. So the total p here equals the total p here. P1 equals P2. And that's what it means for momentum to be conserved. So now let's jump right into a question. A 15-gram bullet strikes and becomes embedded in a 1.24 kilogram block of wood placed on a horizontal surface just in front of the gun. If the coefficient of friction between the block and the surface is 0.28 and the impact drives the block a distance of 11.0 meters before it comes to rest, what was the muzzle speed of the bullet? So we can start very simple with m1 v1 equals m2 v2, because before and after the collision there's only one body moving, so you only need one term on each side. And in this case, v1 can be the muzzle speed, the speed of the bullet, and also m1 would be the mass of the bullet. And the v2 could be the speed right after the collision, so after the bullet strikes the block of wood. And in this case, m2 would be the mass of the bullet plus the mass of the wood, because the bullet becomes embedded in the wood and becomes part of the wood. So we're looking for the muzzle speed, that's v1, so v1 equals m2 v2 over m1. So we know m1 and m2, but we don't know v2, and that's the tricky part about this question. So to solve it, you can do an energy balance, and that says that we can use this information here, the 0.28 and 11.0 meters, with an energy balance. So EI equals EF, and we consider EI to be right after the collision. So EKI plus EPI equals EKF plus EPF. So there's no EPI, there's no EKF, and there's no EPF. So does that mean EKI is equal to 0? Well, no. We can actually say that all the EKI has been converted into heat by friction, so it could just be the work of friction. So EKI equals work of friction. That means that 1 over 2 mv squared equals FF times distance. And let's label these variables. So the mass is m2, because it's after the collision, and the v would be v2. And then we can simplify the right side further. FF is equal to n, which is equal to mu, since it's on a flat surface, mu mg. So that means that this side is mu mg times d, v2 squared. And right now, we're looking to solve our initial equation here. So what we need to find is v2. So isolate this. v2 equals 2 mu, oh, I forgot to label this m here. That would be also m2. So m2 gd over, oh, sorry, we can just cancel out the m2's. Mu gd over, oh yeah, that's it, and square rooted. So the square root of 2 mu gd. And then we can plug that into what we have here, m2 square root of 2 mu, mu gd over m1. m2, okay, let me write it out. 15 grams is equal to 0.015 kg. So if we add 1.24 kg, then that means m2 equals 1.255 kg. So v1 equals 1.255 kg times the square root of 2 times 0.28, which is mu, times 9.80 meters per second, times 11.0 meters, and divide that by m1, which is 0.015 kg. Now put that in the calculator. 2 times 0.28 times 9.8 times 11 square root. You should get 7.77, then times 1.255, and then divide by 0.015. 650 meters per second. Now at first glance this may seem like a lot, but since the mass of a bullet is so low, you can get it to very high speeds with little momentum. And yeah, that's it for this video. Thank you for watching.